Okay guys, so let's look at this logarithmic equation. But before we start, I just wanted to highlight that I'm going to use this property. Okay, so remember this property. If you have log base a of b, then you can change the bases by using this reciprocal property. So log base b of a, you can do that. Okay, so now here I have log base x of 5. That means I can write this as 1 over log base 5 of x. So now let's put it back into the equation. Log base 5 of x equals, now 4, instead of log base x of 5, I can write this as 1 over log base 5 of x plus 3. Then you cross multiply. If you cross multiply, then it's going to be log base 5 of x whole squared, then 4, and this will be 3 times log base 5 of x. Okay, so now let me bring everything to the one side. So it's going to be log base 5 of x whole squared minus 3 log base 5 of x and minus 4 equals 0. Okay, now next is let log base 5 of x is equal to some, some y. Okay, so now I'm going to plug in that in this. So that means this equation would become y squared minus 3y minus 4 equals 0. Equals 0. So now here, this is a quadratic equation. Okay, so what are the, here my a is 1, my b is -3, and my c is -4. So a times c, which is equal to 1 times -4. -4. So tell me two factors of -4 which would add up to give me -3. So I would say -4 and 1. If I multiply, I'll get -4. If I'm going to add them, I'm going to -3. So my factors are y minus 4 times y plus 1 equals 0. So y equals 4 or y equals -1. So y, what is y? We have assumed log base 5 of x is equal to 4 or log base 5 of x is equal to -1. And if I were to convert it into exponential form, I hope you all know how to convert into exponential. Log base of b is equal to some x. That means this can be converted as a to the power of x is equal to b. The same thing. So I'm going to apply the same rule here. So 5 to the power of 4 equals x, or 5 to the power of -1 equals x. So x is equal to 5 times 5, 25. 5 times 5 times 5 times 125. So that's going to be 625. And this will be x is equal to 1 over 5. Okay, so that's the solution.